graphing cosecant and secant functions. So remember, cosecant is the opposite of sine. Okay, remember the way I remember is that they both start with different letters, so that's how I know they're opposites of each other. And then secant is the opposite of cosine. Okay, and again, secant starts with an S, cosine starts with a C. So that's how I know they're opposites of each other. Or at least that's how I remember it. So cosecant, when they want us to graph cosecant, we're going to use a domain between 0 and 4 pi. We're going to include the asymptotes. If you remember, we covered asymptotes and rational functions. Well, our cosecant and our secant have asymptotes as well. So since cosecant and sine are reciprocal functions, we can use a sine of x as a guide and use a dotted curve to graph f of x equals sine of x. Use a unit circle to complete the table of values. So cosecant, let me go ahead and get that unit circle real quick, just so I think I have it memorized, but I don't want to take any chances. Okay, so at 0, it's opposite sign, sorry. At 0, sine is equal to what? Okay, no, not 1. Sine is equal to 0. So if we flip this around and do 1 over 0, this gives us undefined. Okay. And then we have pi over 4. So at pi over 4, our sine is 0.707. So if we flip that around and do 1 divided by 0.707, let me punch that in real quick. I guess it's 1.4. Okay, then at pi over 2, my y value is 1. So when I flip that around, because cosecant is the opposite of sine, that is going to give me 1. And then we have 3 pi over 4, which is 0.707. That's the sine. But we flip it around. So it'll be 1 divided by 0.707. That gives us 1.4 as well. At pi, we're going to have another undefined because sine is equal to 0, but we flip it around for cosecant, and that gives us 1 over 0, so it is undefined. Okay, then 5 pi over 4 is going to give us negative 1.4. I don't want all this to get super messy. Then negative 1, and negative 1.4 again, and then it goes back to undefined. All right, so this is how you graph it. Starting with the sine function. Remember, sine starts right here at 0, 0. And then it goes up, comes back down, goes back up, comes back down, and then back up. And we're just going to make a dotted function. Okay, so this helps us graph cosecant. Okay, if we notice right here we have asymptotes at 0, at pi, and at 2 pi. So at 0, at pi, and at 2 pi. Okay. So if you notice, every time that it crosses the x-axis, that's when we have an asymptote. Okay, so that means I'm going to go ahead and draw another asymptote right here at 3 pi. Whoops, I didn't need to go that far. And another one at 4 pi. Okay. And then here, if I'm making the graph, we have 1.4. So 1.4 would be about right here. And then pi over 2 and 1. And then 3 pi over 4 and 1.4. Then this one's negative 1.4. This is negative 1, and then 1.4, negative 1.4. So this is what your cosecant graph looks like. So it has one little, it kind of looks like a parabola. little parabola going down and one going up. And that's one, what is it called? Why can't I think of the word? One revolution, okay? And then it starts over again. So then we have this part right here, and then this bottom part right here. Okay, so it just keeps repeating the same thing over and over and over again. Okay, one cycle, there you go, there's a word. That's one cycle, and then it starts over again. So that is what your cosecant graph looks like, okay? You have the asymptotes, you have the little curves. This one right here, the sine function, that is just there to help us place the curves, okay? So then from here it says complete the table below. So as the value of b is 1, remember the number being multiplied with the x, that's where we get our b from. You do 2 pi divided by 1 and it gives you 2 pi. Okay. Amplitude. Now we're not going to have an amplitude because we don't have these little curves like that, okay? So it says here none, the graph does not have amplitudes as it goes on forever in the vertical direction, okay? So it's not a wave like our sine and cosine functions are, okay? So now for domain. Now domain is all your x values, okay? So if we notice, it's continuous except for where we have these asymptotes, okay? So it's going to include everything except for the asymptotes. So x cannot equal, if you notice here, it cannot equal 0. We have an asymptote here at pi. We have an asymptote here at 2 pi. We have an asymptote here at 3 pi and at 4 pi. Okay, but we're not going to write them on forever and ever. We're just going to write it as n pi. Okay, any number or any integer, n pi. Okay, so when you're doing this on your delta math, you're only going to see the n pi. You're not going to see 0 pi, 2 pi, 3 pi. It's just any integer n pi. Okay, then we're going to do the range. So how low does our graph go? So if we notice, it points down. But our graph only goes from 1 down to infinity. And then it doesn't start back up till 1, and then it goes up to positive infinity. So remember, we always write from bottom to top. So this is negative infinity, then it goes to negative 1. We have a gap. It starts back up to 1, and then goes to positive infinity. So that's the order that I write. Negative infinity, negative 1. You can never touch negative infinity, but we do touch at 1, negative 1. We have this little gap, so I put the u, and then it starts back up at 1 and goes on to infinity. Okay. So for our domain, our x values cannot equal n pi. Okay. And the reason for that is because we have asymptotes at n pi. Okay. So let's go ahead and try the next one. So here we have secant of x, use the domain from 0 to 4 pi. Include the asymptotes in your graph. Since secant and cosine are reciprocal functions, we can use cosine of x as a guide. Use a dotted curve to graph f of x equals cosine of x. Okay, so starting with cosine, remember cosine starts right here at 1, comes down, back up, comes down, back up. So we make our little curve. Okay. Now the same thing's going to go as the last one. Everywhere where it crosses the x-axis, we're going to have these asymptotes. So right here is where our graph crosses the x-axis. So we're going to have an asymptote here at 5 pi over 2 and at 7 pi over 2. That's where we have our asymptotes. Okay. So our cosecant function, if we see this little peak right here, that means we're going to have a little parabola shape thing here. Okay, remember, still staying within the asymptotes, so you can't cross those. And that completes one cycle, and it starts all over again. Now, of course, we can continue on forever and ever, but that's where we're going to stop. And we put this one right. All right. Now, if we're to use the unit circle, remember the x values are cosine, so at 0 it should be 1, which you notice I already have that there. At pi over 4, it should be 1.4. At pi over 2, it is undefined. At 3 pi over 4, it's going to give me 1.4. At pi, it is going to give me -1. It's actually negative. At 5 pi over 4, it's going to give me -1.4. At 3 pi over 2, it's undefined. At 7 pi over 4, it gives me 1.4. And then at 2 pi, it gives me 1. And then it starts all over again. So again, we're going to go ahead and do the period. So the period here, if there's a number being multiplied with the x here at secant of x, and that would be our period. But in this case, we don't have a number there, it's just 1. So it's 2 pi divided by 1, which is just 2 pi. Okay. So what that means is from 0 to 2 pi, this section here is one complete cycle. So after that, it's the same thing repeated over and over and over again. Okay, amplitude. Remember, there's not going to be an amplitude. Only sine and cosine will have an amplitude, none. And then domain. So our domain is going to cover all the x values except for where we have these asymptotes, which is going to be at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So the pattern that we notice here is that this number here in the front, 1, 3, 5, and 7 are all odd numbers. So x cannot equal these odd numbers. So the way that you write an odd number as a little equation is going to be 2n plus 1. Okay, so 2n plus 1 pi, and all of these are cut in half. It's pi halves, 3 pi halves, 5 pi halves, 7 pi halves. So we're going to take all that and put it over 2. Okay, so our domain can be any number, it just can't equal those numbers because that's where our asymptotes are. So then our asymptotes, I'm going to put here 2n plus 1 pi over 2. All right, then from there, our range. So how low does our graph go? Well, our graph comes all the way down to -infinity, and then it seems to stop at -1. We have a little gap, and our graphs don't start back up from 1, and then they go up to infinity. Okay, so -infinity, -1, starts back up at 1, and then goes all the way up to infinity. Now we go from bottom to top, writing in that order. So -infinity, -1, put the u, and then 1 to infinity. All right. Well, I guess that's it. So that's it for me for today, guys. Thank you. We'll see you next time. Bye.